Hi everybody, and welcome to exercise 6 on page 53. And this is another example of finding work in emptying a tank. Let's take a minute to read this problem together. So we've got a gas station that stores its gasoline in a tank underground in the shape of an upright circular cylinder. We can kind of see a picture over here. And they're telling us that the tank is buried 2 feet below ground level, so there's a gap between the top of the tank and the ground. Okay, and then otherwise, let's see, the tank is half full of gasoline. And then they give us some information about the dimensions of the tank. So its radius is 4 feet. We could maybe draw that into our picture here. And its height is 8 feet. Okay, so that would be the distance here, just from the top to the bottom of the tank. And given all that information, they'd like us to find the work necessary to pump all of the gasoline to ground level. Okay, and when we're doing that, we have to remember that there's kind of a gap between the top of the tank and the ground. We'll see how to figure that in. Okay, well, another interesting feature to this problem that we haven't come across yet is the units. Okay, notice that we're dealing with pounds and feet in this problem. Okay, so this is going to be our first work problem where we don't have metric units. All right, the setup, though, is going to be the same as it always is. We're going to use a slice-by-slice approach. Okay, so imagine taking a slice of the fuel in this tank. Okay, you can see that it kind of has the shape of a circle from the top. And we're going to think about the distance that it needs to travel to go to ground level. That's going to be the distance all the way from the slice up to the ground in our diagram. And we'll start, as we usually do, by seeing if we can figure out what the weight of the slice is going to be, just the slice that we drew. Okay, well, let's first think about units. Okay, so if we're talking English units, what should the units of weight be? Okay, well, you can look back if you need to at the very beginning of this section. We talked about how pounds is one way to measure weight in English units. So that's what we want to end up with here is pounds for the weight of this slice. Okay, and I'm going to start with the number 42 that we have here. Pounds per cubic foot. Okay, that is kind of a strange figure that they're giving us because it sounds like a density, but it's not quite a density. Okay, I'm going to put density in quotation marks. The reason it's not quite a density is that density is normally mass per unit volume, and pounds is a unit of weight. Okay, it's not a mass. And so if you think about what units we need to multiply by to turn this into a weight, we just need to get the feet cubed that are down here to cancel. Okay, so we need to multiply something that has units of feet cubed, and that would be volume. That should do it for us. Volume in feet cubed, because that's going to cancel the feet cubed there and give us pounds, which is what we want. Okay, so it comes down to then, how would we write down an expression for the volume of this slice? Kind of looking over here at the diagram on the right. Okay, well, if you look down the tank, okay, what's the shape of that slice from above? It's going to be a circle. So we'll start with the area of that circle, which should be pi times its radius squared. And then we're going to multiply by its thickness, dy, to turn that into a volume. Okay, so pi times 4 squared times dy. Okay, and if we put all that together, let's see what we've got here. Looking at the numbers, we've got a 42, and then we've got a 4 squared. We could put those together. 42 times 4 squared, I believe, is going to give us 672. And there's a pi in there times the dy. Okay, and we already noticed by canceling units that that's going to be pounds. Okay, and so that should be the weight of our slice. Notice we did not need to multiply by the acceleration of gravity, and the reason is because the weight was kind of already included in this 42 number that we have here. Okay, we got to pounds without figuring in acceleration of gravity. Okay, and so let's see, what's the other component of work besides weight of the slice? It's the distance that the slice travels. Okay, and according to our diagram, that's going to be the y meters that we see here. Okay, and so to get the total work to empty the entire tank, we're just going to take the weight times the distance, these two pieces, and then we're going to integrate. That's going to add up all of the weights of the slices one at a time. So inside the integral is going to go 672 pi y dy. And the last question is the limits of integration here. Okay, now here's where it's going to get a little interesting again. Okay, so let's go back to the diagram and see if we can figure this out. So y is our variable, and remember, y represents the distance that slices have to move. Okay, so we want to talk about the range of distances that these slices of gasoline need to move. So starting with the top slice, how far does that have to move to get to ground level? And notice I said to get to ground level, not to get to the top of the tank, but to get all the way to the ground. Okay, well, it's first going to have to move this half the distance, or half the height of the tank. That's 4 feet. And then there's this additional 2 feet. Okay, that's kind of too small for me to write, but there's this gap of 2 feet to get from the top of the tank to ground level. So how much is that all together? We need to take 8 plus 2. That's going to be, or I'm sorry, 4 plus 2, because we're going half the distance of the tank plus the 2. That's going to be a total distance of 6. Okay, so if you look down at the integral here for a minute again, lower limit is going to be 6 because that's the distance that top slice needs to move. Okay, and then we pump out our gasoline and eventually we come to the very bottom of the tank. And how far does that bottom slice need to move? Okay, well, that one is going to have to move the entire 8 feet, okay, to get to the top of the tank, plus an additional 2 feet to get to ground level. That's 8 plus 2 is 10. Okay, so looking down at our integral again, that's going to give us an upper limit of 10. Okay, so our limits are made more interesting by the fact that our tank is buried underground in this case. All right, well, we don't have much space, so we better be efficient when we do this integral. So let's see, we've got 672 pi, and antiderivative for y is going to be y squared over 2. Okay, we will evaluate between 10 and 6, and let's see what we get here. So upper limit will be 10 squared over 2 when we substitute it in. Lower limit's going to be 6 squared over 2. Okay, and then last step would be just to go to your calculator and see what this works out to be. This is going to be about 557. I'm going to round just to the nearest unit here. And last question is, what would the units be here? Okay, and actually, asking you that question made me notice a mistake that I made. Do you see it? You might have noticed this way long before. Meters, that is not the units that we are using, is it? Okay, what should I have written there? Okay, we are measuring distance in feet, not meters. Okay, so with that correction, work should be in units of pounds times feet in our case, and that means foot-pounds should be our final units here. There's that strange English unit for work, and there's our answer.